Okay, so let's see. Notes 19.0, characteristics of sine and cosine graphs. Now at this point you should have your sine graph done. Your cosine graph you might still be finishing for homework. But I wanted to talk about them. Here's your sine graph and here's your cosine graph. They look very, very, very similar. The biggest difference is what's going on at the origin. Or I should say at y equals 0, or at x equals 0, I'm sorry. In your sine graph, the origin, it is right between a valley and a hill, if you will. Whereas over here, when x equals 0 on a cosine graph, you're actually at the top of a hill. So it's different in that regard as far as what is high or what is low and at what location. So let's talk about a sine graph. A sine graph, the domain, the x values, it goes on and on forever. If you think about our little project that we did, the only reason we stopped was because of how long our string was, and we didn't want to keep going forever and ever. But if I had a string that was as long as I wanted it to be, I could keep going around that circle forever and ever and ever. So my domain would be all real numbers. My range would be how high or how low it goes. Now this particular one, just like we graphed, goes as high as 1 and as low as -1. So for this one I would say -1 less than or equal to y, which is less than or equal to 1. Okay? So for both sine and cosine, they can both go on forever and ever in either direction. And the range would be -1 is less than or equal to y is less than or equal to 1. Sometimes this height and the highest and lowest points might change, so your range could change for different graphs. Let's see. So for y equals a sine b theta. Now a and b are different types of transformations we can do on here. They're going to help us make them taller. They're going to help us spread them out this way, make the wavelengths longer. A and B will change things. So when you have a sine b theta or a cosine b theta, your domain will still be all real numbers because again you can go around that circle as many times as you want to. Your range will be negative absolute value of a is less than or equal to y is less than or equal to positive absolute value of a. Now that's a little bit confusing, but we'll see that more in depth later. Let's see, some other words that we need to know. A cycle. A cycle is the shortest repeating part of a graph. And here's how I like to remember it. I like to remember that on a sine graph, you start at the middle, and then you go to the top, and then you go back down to the middle, and then to the bottom, and then to the middle. And that would be considered one cycle. Okay? One cycle from middle, top, middle, bottom, middle. Now cosine, it's a little bit different. It starts at the top, then goes to the middle, then goes to the bottom, then goes to the middle, then goes to the top. Almost looks like Teenage Mutant Ninja Turtles there. Anyways, that would be one cycle there, from the top all the way down to the bottom, and then back up to the top. Now, a period is the horizontal length of that cycle. So it's how long or how far or how wide, maybe would be a best way of saying, is that cycle. So this one, it looks like it goes from 0 to 2 pi. So our period would be considered 2 pi in this case. So for our graphs of y equals sine theta and y equals cosine theta, our period is 2 pi, because you can see I just showed you cosine, and if I go from here, it goes from 0 to 2 pi right there. When we throw in the a and the b, which can do different things to it, our period is actually a little different to figure out. It's 2 pi divided by the absolute value of b. That's an absolute value sign. So here's our b value. We take 2 pi and we divide it by that, as long as it's positive. Okay? And we're going to get more practice. Today we're just kind of learning the vocabularies. We'll get more practice actually find these things. Amplitude. Amplitude is the distance from the x-axis to the highest or lowest point. Now, I say from the x-axis that will actually change because sometimes we're going to shift our graphs up or down, and so it's from whatever you're treating like the x-axis, wherever your middle is when we're talking about middle. So for each of these graphs, the highest point was 1 and the lowest point was 1. So we would consider this line, the x-axis, basically like our center. And so since at most it only goes either up 1 or down 1, we would say our amplitude is 1. It's kind of like how tall is it? When we are talking about a sine b theta, again, when we throw in those extra numbers, our amplitude would be a, and we always take the absolute value of it. Amplitude's always positive. And we'll see what happens when we make things negative in the future in a little bit. Maxima and minima. Maxima are the highest points. And on some graphs, there might be only one highest point, but on a sine graph or a cosine graph, you hit that highest point over and over and over again. And same thing with the minima. That would be your lowest points. And again, I'm putting that S in parentheses because sometimes, for example, if you're graphing a parabola, you have a minimum value that's right there, and there's only one of them. But when we have this wavelength, we keep hitting that minimum value numerous times. Okay? And then zeros and roots would be wherever the graph touches the x-axis, just like it was when we learned about them with polynomials last semester. It's wherever it crosses the x-axis. So in my graph here, I have a 0 here, 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 and if my graph extended, I could continue on there. On my cosine graph, here, 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 and so on. Let's see, for y equals sine theta and y equals a sine b theta. So this is specifically for sine graphs. We call them 5-point graphs. I don't really use the term 5-point graphs. I use my middle, top, middle, bottom, middle, and that'll make more sense once we actually graph one. The zeros are located at the beginning, halfway into the period, and at the end of the period, blah, 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 blah. It's wherever you see the middle in the middle, top, middle, bottom, middle. So these right here would be your zeros, wherever you hit the middle. And let's see, for cosine, same thing. She's got a lot of stuff going on here. We would use the top, middle, bottom, middle, top, just like I had up here. Top, middle, bottom, middle, top. And again, the zeros would happen wherever you hit the middle. Okay. All right. So that's really all I want you to know right now for today. We're going to go on further with this later. So just make sure you get all these definitions down. You kind of know a little bit about what I'm talking about when I talk about these things.